Now this next section we need to talk about is combinations. And we need to first be able to distinguish between permutations and combinations. So recall the alarm code example we did at the last section, where the codes 1722 and 2271 are different permutations since the order of the digits make a difference. There are many instances where order does not make a difference. For instance, in blackjack, the order how one receives cards does not matter since it makes no difference if we get an ace first and then a 10 second or vice versa. What matters is that one card's an ace and the other one's a 10. Such arrangement of objects where order is not important is called a combination. So a combination is an arrangement of R objects chosen from N objects where order of how the objects are selected does not matter and repetition is not allowed. With combination, order is irrelevant. Again, order makes no difference. The notation NCR means that we have a combination of N objects taken R at a time without repetition where order is not important. So keep in mind when we're talking about combinations, the arrangements ADS and DSA are considered to be the same combination because the order does not matter. This is a much more formal definite combination that we experience in everyday world. So let's turn to our workbook and look at problems 1 through 4. So we want to determine if the following is a permutation or a combination. So a 3-member committee is to be selected from people that serve on the student government for appeals committee. Does this problem involve a permutation or a combination? So ask yourself, is order important? In this case, no. So this would be a combination. Let's try this next one. All the students in the student government are running for president, first place, first vice president, second place, second vice president, third place. Does this problem involve a permutation or a combination? Well, now order is important because depending on which order you're selecting, you're either going to be president, first vice president or second vice president. So this would be a permutation. Order makes a difference. The combination of a lot consists of 3 numbers ranging from 0 to 39 with repetition on. Is the combination for a lot a permutation or a combination? This is problem number 3. And here's where we misuse the word combination. Because the order does matter. You have to put the digits in the correct order on combination or else it's not going to work. So it should not be called a combination lock, it should be called a permutation lock. So again, you have to think about that in mathematics. We are more formal with our definitions. And we actually misuse the word combination when we're talking about locks. It really should be a permutation lock. Let's list all the combinations of A, B, C, D, and E taken 3 at a time. So remember, order doesn't matter, so I'm just going to be systematic. So I could first do A, B, and C. I could do A, B, and D. And I could do A, B, and E. I could then do A, C, D, A, C, E, and A, D, E. So now I've exhausted all the ones involving A. So let's go with B. I can do B, C, D, B, C, E, and B, D, E. So we've used up all the B's, and now the only thing left is A, D, E. So I've got a total of 10 combinations. Now, if I take my calculator and I go and I do 5 PRB. Now notice option number 2 is NCR. You can probably guess that's going to be our combination. And then we're going to do 3 and then hit enter. And that's also 10. Okay, so let's see how that works. Solving counting problems using combinations. In a permutation, we can order 3 letters 6 different ways. So order had been important in the last example. The total number permutation would have been 60. So if I take 5 PRB NPR 3, I get 60. And notice that's equal to 6 times 10, what we had previously. 6 times 10 is 60. And that 10 is equal to 3 factorial. That 6 is equal to 3 factorial. So we know that 5p3 is equal to 5 factor over 5 minus 3 factorial, which is 60. This means that 3 factorial times 5c3 equals 5p3. If we divide both sides by 3 factorial, that gives us how to find 5c3. We can then generalize this result. The arrangement of R objects selected from n distinct objects where type is not allowed and order is not important is n factorial over n minus r factorial times r factorial. Now again, with this one, you can do it by hand. You have the formula on the formula sheet, but you can also more easily do it on the calculator. So let's go back to our workbook to page 140. And let's take a look at problem number 5. So here, we're first just going to do a few exercises, just make sure we can work with the notation. So I'm going to do 8 PRB, option number 2, 1, hit enter. That gives us 8. Now I'm going to do the next one, 7, hit PRB, 2, and then 4, hit enter. That's 35. Just remember, anytime you're entering this in, you're always putting the larger number first. So for the last one, I'm going to do 74. Probability key, option 2, 71. Alright, so let's revisit the problems from the previous page. We're going to kind of add some more information so we can do them now. A 3-member committee is to be selected from 15 people that serve on a student government for appeals committee. How many ways can this be done? So again, ask yourself, does order make a difference? Here, no. So this is going to be a combination. I've got 15 people and I'm selecting 3. So 15, option number 2, 3. So that's 455. Alright, now let's change it up a little bit. All the 15 students in the student government are running for president, first place, first vice president, second place, and second vice president, third place. How many ways can this be done? Now, order is important because how you select it's going to mean you're going to be president, first vice president, or second vice president. So this is going to be a permutation. I'm going to do 15. I'm going to do my first option this time on my probability. And that gives us 2,730. Now notice something. You have three different positions. And 3 factorial is 6. Take 455 times 6. You should get the 2,730. Let's try number 8. How many ways can a committee of 2 teachers and 3 parents be selected from 8 teachers and 10 parents? Well, this is really 2 combination problems in one. First, I got the teachers. I'm selecting 2 from 8. Now, order doesn't matter here, so this is a combination. So this is 8C2. Then I've got the parents. I'm selecting 3 parents from 10 parents. So again, the larger number first, 10, C3. And then using the fundamental counting principle, here are the number of ways I can select the teachers. Here is now the ways that I can select the parents. So I'm going to be multiplying these two answers. So let's go and do the first one. 8 combination 2. 8 objects taken 2 at a time. That's 28. And then let's do 10. Option number 2 in our probability 3. Enter. That's 120. And we're going to take 28 times 120. So that gives us 3,360 ways. Now this calculator will let you enter this all as one line. So let's see how that would work. I would do 8 by probability key, option 2, and I do multiplication here. And I type in the 10, probability key, option number 2, 3, and hit enter. So you could also enter it as all in one line as well.